Hey everyone, today we are diving into fluid mechanics, starting with the absolute fundamentals, properties of fluid. Before we look at density or viscosity, what exactly is fluid? A fluid is any substance that cannot withstand a shear force. It continuously deforms under shear stress, that is called fluid. Fluid includes both liquid and gas. Now we will see four most critical properties that you need to understand. The first property is mass density, denoted by Greek letter rho. This is simply mass per unit volume. Think of it as how tightly packed the molecules are. For engineering calculations, always remember the standard benchmark, that is, water at 4 degrees Celsius has density of exactly 1000 kg per meter cube. If you are dealing with gases, density changes drastically with temperature and pressure. But for liquids, we assume it's mostly constant. Even for liquid also the density changes, but the change is very slight or insignificant. So you don't have to consider that change. So what's the formula for mass density? Rho is equal to mass per volume and its unit kg per meter cube. Yeah, as I said, try to remember the benchmark note, which is density of water at 4 degrees Celsius, that is 1000 kg per meter cube. Okay. Next is next property is specific weight. It is it is also denoted by gamma. So what's specific weight? As we know, density is mass per volume, but the specific weight is weight per volume. What's the difference between mass and weight? Mass is just a quantity, but weight is the force created or generated by that mass due to gravity. So what is weight? Weight is equal to mass into gravity. So what's the formula? Specific weight is denoted by this both formula, both symbols, gamma and this is W. So equal to weight by volume. What is weight? Mass into gravity divided by volume, which is mass by volume is density. Density into gravity is what? Specific weight, and its unit Newton per meter cube. Why? Uh, Obviously, this volumes unit is meter cube. Mass is kg into mass into gravity is basically force. So this unit is Newton. Now property number three, specific gravity. This is pure dimensionless number because it's a ratio. It tells you how heavy a fluid is compared to a standard reference fluid. For liquids, that reference is always water. Okay. If a chemical has specific gravity of zero point 0.8, it means it's zero point 0.8 times as dense as water. So its density is zero point 0.8 into 1000, which is 800 kg per meter cube, and it will float on water. If specific gravity is 1.2, then the gravity will be 1.2 into 1000, which is 1200 kg per meter cube. Yeah, so if the specific gravity is less than 1, it is lighter than water, so it will float on water. If the specific gravity is more than 1, then it is heavier than water, so that it will sink in water. What's the formula? As I said, density of fluid divided by density of water, which is 1000 kg per meter cube. Okay, so you divide density by density, so it's a dimensionless number. It has no units. So if you are given specific gravity of a fluid which is zero point 0.8, then how do you calculate its density? You just multiply specific gravity with 1000. Water comes is your density. Okay. Now final property is specific volume. This is exact mathematical inverse of mass density. Okay. What does it represent? You take 1 kg of some fluid and how much volume it occupies. Okay. More the specific volume, lesser the density, because it's just inverse. More the specific volume, more the specific volume, then 1 kg of that fluid uh, uh, takes a lot of more higher the volume. Okay. You will use this property heavily when you get into chemical engineering, thermodynamics, and steam tables. Since it's inverse of density, its unit is simply cubic meter per kilogram. What's the formula? The specific volume is denoted by nu, which is volume by mass, which is inverse of density. So units is opposite, I mean reverse of density, which is meter cube per kg. Okay. To summarize, we have covered mass density, specific weight, specific gravity, and specific volume. Okay. In our next video, we will understand viscosity and Newton's law of viscosity, which dictates how fluids actually flow inside a pipe. Hit subscribe, keep your pens ready, and I will see you in the next one.